So remember, when you distribute, make sure it gets multiplied to everything. 6x squared minus 8x. All right, so again, we want to make sure that we're in descending order of the exponents after we combine like terms. All right, so this should be pretty easy. Just a review of what we just came from, taking the quiz. 2.1, multiplying. All right, so when we factor, we're going to be doing just the reverse. Right? So factoring is the reverse of multiplying. So these are factors, x minus 3x plus 3 of x squared minus 9. 2x plus 6, 4x minus 8 are factors of this trinomial. And then 2x, 3x minus 4 are factors of this polynomial. All right, so when we factor, all it is finding numbers that divide evenly into a certain number. So you can see the factors of 10, for example, are 1, 2, 5, and 10. Each of those numbers divide evenly into 10. And those are the only numbers that divide, other than their negatives. The factors of a variable cubed are x to the first, x to the second, and x to the third. You can see what factors are for numbers and factors for variables raised to exponents. Now, the GCF, or the largest or the greatest common factor, is the greatest number or variable that divides evenly into 2 or more terms. So if we want to find the greatest common factor between 6 and 9, you can list all the factors of 6, which are 1, 2, 3, and 6, all the factors of 9, 1, 3, and 9, and the largest number that they have in common is 3. So 3 is the GCF of 6 and 9. All right. On variables, x to the third and x to the fifth, okay, you can see I listed them all out, all the factors of each one, and the one that they have in common, which is the biggest, is x to the third. So when you're looking at exponents, you're going to always take the smallest exponent between the two. All right, so now let's go ahead and factor. So the first step in factoring is look for that GCF of all your terms. So 5v squared and 5v. So what would the GCF be between those two terms? Yeah. Okay, 5 is the number, but you got v squared and v. So since they're both variables, v, they both have exponents. One's a 2 and one's a 1. So what's the GCF of v squared and v going to be? So we got the 5 from the 5 and 5, okay? But you have a v squared and a v. They're both the exactly same variable. So you got to treat it just like we did here, x cubed and x to the fifth. How do we find the GCF of variables with exponents? Take the one with the smallest exponent. Well, what's the smallest exponent between v squared and v? V, right? V is the first. 1 smaller than 2. So v, the first, is the GCF between v squared and v. So the GCF between these two terms are going to be 5v. All right, then we put parentheses. And now what you're going to do is divide each of these two terms. You're just dividing this by 5v. So if we divide 5v squared by 5v, the 5 cancel. V squared divided by v is just v. minus. And then when we divide 5b by 5b, that's 1. All right, so this is factored all the way. So again, what I'm doing to get what's inside the parentheses, I'm taking 5v squared first. So you're basically just doing this in your head and dividing it by that GCF. Well, if you simplify this, remember you subtract exponents, that's how I get v. Then if I take the 5v and divide it by the GCF again, I get 1. So that's where I'm getting the v and the 1 from. Just taking the first term divided by 5v, second term divided by 5v. And if you wanted to check to see if you were right, you can distribute that in, and you have to get the original problem. 5b times b is 5b squared. 5b times 1 is 5b. All right, number 2. What would the GCF be? Yes. Yes, 2n cubed. All right, so 2n cubed goes on the outside. All right, now we're going to take each of those two terms and divide them by 2n cubed. All right, so 2n to the 4th divided by 2n to the 3rd is going to be n. Minus. Now, what's 18n to the 3rd divided by 2n to the 3rd going to be? Yeah, good. It's going to be 9. So we'll have n minus 9 instead. All right, number 3. What would the GCF be? Yeah. Good. 4x squared. All right, so now we're going to take each of those two terms, divide them by 4x squared. What's going to be the first term inside the parentheses? X, good, plus, and then 16x squared divided by 4x squared becomes what? 4. So x plus 4. All right, number 4. What's the GCF? Good, 2x squared. And then what's going to be on the inside? What's the first term going to be? X, and then minus 8 fifths. X minus 8. All right. Again, if you're not sure if you're right, just take your answer and distribute back in. You have to get the original. All right. So first step, always in factoring, look and see if there's a GCF you can factor out. All right. Second step is look and see how many terms you even have. So if there's 2 terms left over after we pull a GCF, we want to look and see if we have what's called the difference of squares. All right, so a difference of squares means there's 2 terms. There's a subtraction sign, that's the difference. And then the first term and the second term are both perfect squares. Okay, like 1, 4, 9, 16, 25, 36, 49, 64, 100, 81. All right, and if there's a variable involved, if there's an x squared in there, okay, it could have an x squared. So x squared is an even number, which means it's a square. So if we have the first term is a perfect square, the second term is a square, and there's a minus, then it's going to factor into this pattern right here. Right? These are conjugates. Okay? Kind of remember how we did the complex or the conjugates on the imaginary numbers. Okay, so you can see both terms are the same. The second term has opposite signs. So when we want to factor a difference of squares, okay, you want to first recognize that they're both perfect squares, both terms, and there's a minus sign. So what we're going to do is write 2 sets of parentheses. You're going to put one plus and one's minus. It doesn't matter which one's first, which one's minus, which one's plus. And all you have to do is think of how square roots work. Okay, if you take the square root of x squared, it's x. And the square root of 4 is 2. So x squared minus 4 is going to factor into x plus 2 and x minus 2. So we're breaking up that x squared into two terms being multiplied together. X times x squared. We're breaking up the 4 into two numbers being multiplied together the same. It has to be 2. Right? So if you think of how square roots work, that's where the x and 2 really are coming from. The square root of 4 is 2. The square root of x squared is x. All right, B, x squared minus 25. So both of these are perfect squares, and there's a minus sign. So then it factors into two terms, two binomials. Okay, one's plus, one's minus. Break up the x squared, x, and x. Break up the 25, or take the square root of it, it's 5. So x plus 5, x minus 5. All right, C. X squared is a perfect square, 16y squared is a perfect square, and there's a minus sign. So one's plus, one's minus. We're going to break up the x squared, x and x. How can we break up the 16y squared? 4y, yeah. So 4y, 4y. Right. And so then that's factored. All right, again, if you want to check real quick, just multiply the first terms together, that's x squared. Multiply the last terms together, that's negative 16. All right, D. Okay, both of these are perfect squares with a minus sign. So how do we break up 4x squared? Okay, what's it going to be? 2x, good. So 2x and 2x. And then we can break up 9 as what? 3 and 3, right. The square root of 9 is 3. All right, now E, 2 is not a perfect square and 32 is not a perfect square. But there is a GCF we can factor out first. So that has to be your first step always anyway. So what's the GCF? 2, yeah. So we're going to factor a 2 out first. Okay, we're going to divide those by 2, so we'll be left with x squared minus 16. Now, x squared and 16 are both perfect squares, so that will factor further into two more binomials. One's plus, one's minus. We're going to bring that 2 directly down in front. Right, we break up the x squared as x and x. And we can break 16 up as 4 and 4. All right, and then F, there's a GCF that we can factor out. What is it? 30. 30 goes into both of those. 10 does, but there's a bigger one. We always want to pull that biggest one, so it's going to be 30. So what's going to be left on the inside when we factor 30 out? X squared minus 1. Good. Now, x squared and 1 are both perfect squares. You can square root those. So that means that this is going to factor further. We'll bring that 30 down because we did pull it out. Okay, one's plus, one's minus. Break up the x squared as x and x. And we can break up the 1. What's the square root of 1? 1. All right, so we get 30 times x plus 1, x minus 1. All right, now 3 terms. So 3 terms, we have a trinomial. So the standard form of a trinomial is ax squared plus bx plus c. So when we factor a trinomial, the idea is to multiply the first number in front. Remember, this has to be in descending order. So the first number and the last number get multiplied together. That number is going to go on top. And then the middle number, that b part, that's going to go on the bottom. So we need 2 numbers that multiply to the top number and add to the bottom number. So multiply to the top and add to the bottom. All right. So let's go ahead and do A. So the first thing we're going to do is draw x. So we'll call this the x method. So anytime you have 3 terms, just think of the x method. All right, so there's a 1 in front of the x squared. This is just to get you used to the process. We multiply the 1 and the 45 together, so that's 45 on top. And then the middle term, negative 14, goes on the bottom. So we need 2 numbers that multiply to the top number, 45, but add to the bottom number, negative 14. So this is where multiplication comes in from elementary school. All right, so what 2 numbers multiply to 45 but add to negative 14? Good, and they would both have to be negative, right, to get a negative 14. All right, so now all we have to do is write our 2 binomials. And we're going to write x minus 9 and x minus 5. Let's factor it all the way. All right, b, same thing. Right. Again, think of a 1 in front of that x squared. It's going to come into play a little bit later, but just so you need to see that there is a number in front. All right, so 1 times 4 is 4 on top. The middle number is 4 on the bottom. 2 numbers that multiply to 4 but add to 4. 2 and 2, good. So x plus 2, x plus 2. All right, C. All right, negative 72 on top, negative 1 on the bottom. There's a negative 1 in front of that x in the middle. So 2 numbers that multiply to negative 72 but add to negative 1. Okay, so 9 and 8, right? That multiplies 72. So now you just have to get your signs right. So it's got to be a negative 9 and a positive 8 to add to get negative 1. All right, so the negative has to be on the 9. All right, so then it's x minus 9, x plus 8. All right, so go ahead and do D, E, and F. All right, so changing that to a 4, it should be 6 and negative 2. So x plus 6, x minus 2. All right, so this last method of factoring, we're going to use the same method as before, but we're going to do one extra step. All right, so we started off exactly the same way. So do our x. This time you have to make sure that you multiply the number in front and the number at the end together. Right? So 8 times 4, that's going to be 32 on top. And then the middle number again stays 33. And again, we need two numbers that multiply to the top but add to the bottom. So what multiplies to 32 but adds to 33? Yeah, 32 and 1. Don't forget that. That's a lot of people forget that, the 1. Okay. Now, some of you have been taught using a grouping method. You can turn the 3-term polynomial into 4 terms and then use grouping, and that's totally fine. I'm just going to show you a quicker way to do it, and if you've seen it before, then great. So this is called the bottoms up. So you start off exactly the same way as before, except now because there's a number in front, what we're going to do is divide both of these numbers by that number in front. Then if you can simplify either of the fractions, you have to simplify. All right. So again, that number right there goes underneath both of them. Now, 32 over 8 can simplify that fraction. What's 32 over 8 simplify to? 4, yeah. And the 1/8 isn't going to. All right, so this is really just 4. All right, so now we can write our 2 sets of parentheses. One of them is going to be x plus 4. That's from the 4. Now, the other one, this is where the bottoms up comes in. This bottom number comes up. It'll come up next to the x. Okay? So really what it says right now is x plus an 8. But you can't have a fraction in here. So what you do is to get rid of the fraction, you take that denominator and you move it up next to the x. So we move it from the bottom up next to the x. So it becomes 8x plus 1. All right, so let's go ahead and do b. So again, we'll multiply the first and last together. That's negative 36. 5 is on the bottom. So two numbers that multiply to negative 36 but add to 5. Nine and 4? Yeah. So it's going to be 9 and negative 4, because they have to add to positive 5. All right, so remember all your factors of like 36. You got 13, 12 and 3, 9 and 4, 18 and 2. Right. So there's more than just one of them. All right, so then we're leading off with a 9. So we're going to divide each of these by 9. All right, and then simplify the fraction that you can. 9 over 9 will simplify to 1. Negative 4/9 doesn't simplify. So now we'll write our two factors. One of them is x plus 1. The other one, that 9 is going to come up next to the x, and then it's minus 4. So keep the negative on the 4. All right, now C, there's a GCF that we can factor out because they're all even numbers. So it's just going to make it easier on you. I mean, you could do the 4 and the negative 8. You're just going to get bigger numbers. All right, so it's always easier. Pull out the GCF if there is one first. So we can factor out a 2. So 2x squared plus 7x minus 4. All right, so factor the 2 out. I divided each of the terms by 2. All right, so now when I do my x, okay, it's just based off this 2x squared plus 7x minus 4 part. All right, so again, I have to multiply this 2 times this negative fourth, so that's negative 8 on top, positive 7 on the bottom. Two numbers that multiply to negative 8 but add to 7. Positive 8, negative 1. Okay. All right, and because I'm leading off with a 2, I have to divide by 2. That's that 2 right there. 8 over 2 will simplify to 4. Negative a half doesn't. I'll write my 2 sets of parentheses. X plus 4. The negative 1/2, I'm going to take the 2 and from the denominator, move it up next to the x, and then minus 1. Now this 2 that I pulled out at the very beginning, that GCF, that's going to come straight down in front. All right, so go ahead and try D. See if you can do that bottom side. There's no GCF on D, so just multiply the 5 and the 3 together. All right, and then E, there's a GCF that we want to factor out first. We can pull the 3 out. So dividing each of those by 3, we're going to get 2x squared plus 3x minus 5. All right, so now we'll do our x. We'll multiply the 2 and the negative 5 together. That's negative 10 on top, 3 on the bottom. All right, two numbers that multiplied negative 10 but add to 3. Okay, 5 and negative 2. And we're leading off with a 2 here, so we have to divide by 2. Simplify the fractions. That will simplify. Negative 2 over 2 will simplify to negative 1. All right, so then we have, doesn't matter the order. All right, 2x plus 5, x minus 1, or you have x minus 1 first, 2x plus 5 second. And then the 3 that we pulled out at the very beginning goes in front. All right, go ahead and do that last one, F. There's no GCF that you have to factor out.